A solution that contains 605 milligrams of NaHSO4, that's sodium hydrogen sulfate, in 100 centimeters cube of solution has a pH of 1.72. Calculate the value of Ka for the hydrogen sulfate ion that is behaving as a weak acid. Give your answer to 3 significant figures. Okay. So first things first, we know that we have pH is equals to minus log H plus. So that's the first equation that we know. And then we know that we're looking for the Ka, so we can find the splitting of this. Sorry, the hydrogen sulfate ions, because this is what it says. Calculate the Ka for the hydrogen sulfate ion that is behaving as a weak acid. So that means you have a splitting pattern there. So HSO4 minus will give you H plus plus SO4 2 minus. Yep, that's right. Wait, what did Cass say? Let me just read that. Find H plus from pH, then find moles of NaHSO4, then find concentration, then find Ka by squaring H plus, divide this by CO. Yep, that's right. So we have here the splitting. As you said, the ratio is 1:1, so that's why we have the H plus S squared after this. So we can make the Ka equation first. It's always products divided by reactants here, by the way. So you have the products H plus, SO4 2 minus over reactants. Again, H plus concentration is equal to the SO4 2 minus concentration because the ratio is 1:1. So when you put that together, you get H plus squared over HSO4 minus. Okay, so now we can find the concentration of H plus, we can find the concentration of HSO4 minus. So finding the concentration of H plus first. We have pH equals minus log H plus, and the pH is 1.72. So you have 1.72 equals minus log H plus. So that means the concentration of hydrogen is 10 to the minus 1.72. You can put that into your calculator, which I don't have one, but I do know what the value is. (0.0191 mole dm minus 3. So we know the hydrogen concentration. Now we need to know the concentration of the HSO4 minus. We can do that by using these. Mass in chemistry must always be in grams, so you can convert that by dividing by 1,000. So that's 0.605 grams. And we can get the moles by dividing by mR. So you have mole of NaHSO4 minus 0.605 divided by 23 plus 1 plus 32 plus 16 times 4. 5.04 times 10 to the minus 3 moles. In the splitting, they will again be 1:1. And so, the mole of HSO4 minus will be the same. 5.04 times 10 to the minus 3 moles. Again, this is AQA Chemistry, paper 3, 2019. It's an A-level paper. So we know the moles of the HSO4. we know the volume of the solution. So concentration is mole over volume, 5.04 times 10 to the minus 3 divided by, again, tricky here because they gave you it in centimeters cube. So you have to divide that by 1,000. So divide by 0.1, you get 5.04 times 10 to the minus 2 mole dm minus 3. So now we know the hydrogen concentration, we know the HO4 minus concentration, we can find our Ka. So Ka will be 0.0191 squared over 5.04 times 10 to the minus 2. And that gives us 1.17 times 10 to the minus 2. Let's check the units now. The units of the H plus is mole per dm cube, so is the HSO4 minus. So then you have mole dm minus 3 squared divided by mole dm minus 3. That cancels the square, you're left with that. So the unit is mole dm minus 3. Any questions on this? Okay, I think I'm getting a lot of questions or something, I'm not sure, but uni is much easier than this. I actually agree with that. Please, what is the times you do this? So I do usually do it at 10:30 up until like 12. But I have a lesson after this. I have a student at 11 till 12 today. So I'm gonna do this until 11 for today and continue after 12 again. But yes, usually I do it around 10:30 until 12 and so on. I do both A-levels and GCSE. Today, I'm continuing with the A-level that we did yesterday, so that's what we're doing right now. Any other question? That's a whole lot of working for just one question. Yep, that is true, but it is 6 marks. So it's basically free 6 marks. But yeah, that's how you do it. Find the concentration of H plus, find the concentration of the HSO4, find the units. It's pretty simple. I completely agree. A-level biology is the most difficult in my opinion. Okay, so in 2.5, some sodium sulfate is dissolved in a sample of the solution from question 0.02.4. Explain why this increases the pH of the solution. Okay, so the sodium sulfate is dissolved in a sample of the solution. This means that we're kind of adding more of the HSO4 minus here. Sorry, more of the SO42 minus here. We know the equilibrium looks like this. So if you increase the concentration here, increasing concentration always moves the equilibrium to the opposite side. So if you increase it over here, then it will move there. Think of it this way. If you're increasing something, you have too much of it. You want to decrease it. So if you decrease it, you need to make the product on the other side. That's why it goes to the left. And so increasing, obviously write this down in actual words, I'm just lazy. Increasing concentration of SO42 minus by adding sodium sulfate will shift the equilibrium, EQM, to the left. Hence, H plus concentration decreases. And so pH increases. meaning it's less acidic, more alkaline. The more hydrogen you have, the more acidic it will be. So again, let me explain this because I think someone said I don't understand. So we have the sodium sulfate. Sodium sulfate is Na2SO4. And it's dissolved, which means it will split up to form Na plus SO4 2 minus. That means you're adding more of these. If you add more of these, then you will have more of it on this side, increasing the concentration here. Increasing the concentration of SO4 will shift the equilibrium to the other side, to the left. And so you get more of this one, less of these ones. And if you have more of the left side, less of the H plus, pH will increase because you have less hydrogen ions. Hydrogen ions makes things more acidic. So if you have less of it, it will become more alkaline. I do have a YouTube channel. It's where I post the lives that I do. So I post a recording there. It's PCFG Study. That's my YouTube. So you don't understand why the left side would be more? The left side will be more because of the Le Chatelier principle. Le Chatelier principle states that if you increase the concentration, it will shift the other side. Yes, so it shifts to counteract the change. That's right. Okay, next question. Here we have a electrode potential, electrolysis. Oh my God, I can't speak, sorry. Electrolytic cell. That's what we have here. And we're measuring the electrode potential using the voltmeter. Yeah, I mean, you guys got it right. So easy 1 mark, salt bridge. A is the salt bridge. And the purpose of it is so that the electrons can flow, or the ions can flow specifically. Yes, that's correct. So flow of ions, or you can even say complete the circuit. This is a keyword. This is not triple science. This is A level. I will be doing GCSEs in the future. Name the substance used as electrode B. Okay. So it says that we're looking for the standard electrode potential. That is the hydrogen electric cell. So this must be platinum, as you guys said. That's right. Next one. Complete table 1 to identify C, D, and E from figure 1. Include the essential conditions for each. Okay. So C, D, and E. Let's write it down here because we kind of, yeah. So C must be a, what's the word? Acid. And the acid, we can use HCl or H2SO4, up to you. But the condition is that it must be 1 molar, which means it must be 1 mole Dm minus 3. That's the standard. That's right, 1 mole Dm minus 3. This is platinum. Because we're using the hydrogen electrode here. A standard hydrogen electrode cell always uses platinum. And the pressure of the gas entering, which is going to be H2 gas here, must always be standard, which is 100 kPa. And temperature 298 K, that's very true. And then E, we're looking at the iron. It says here we're looking for iron, Fe3 plus, Fe2 plus, so you can use either one of them. It will be the Fe, Cl2, or any other Fe, Fe solutions. You can say FeCl2 and FeCl3, or you can just say Fe2 plus, Fe3 plus, but the condition must be 1 mole Dm minus 3. So we have HCl, 1 mole Dm minus 3, H2, what was it? It was 100 kPa, and Fe2 plus slash Fe3 plus, 1 mole Dm minus 3. Okay. Again, these are stuff that you need to know, especially that one. That one you need to memorize. Temperature 298K, that's right. So I can put that over here. The standard electrode potential, E standard, for the Fe3 plus Fe2 plus electrode is plus 0.77. Give the ionic equation for the overall reaction in the cell in figure 1. State the changes that needs to be made to the apparatus in figure 1 to show the cell reaction to go to completion. Okay, so we know we're going from Fe3 plus to Fe2 plus. So Fe3 plus to Fe2 plus. Does this gain or lose electrons? This gains electrons, that's right. Very good. So this gains electrons. And if you look at this, the only way they can gain the electron is from the hydrogen, isn't it? And it comes in as hydrogen gas. So the hydrogen will be in the molecule form here, giving the electrons to form H+. So I'm going to put that at the bottom here to make the equation. So we have hydrogen to give you 2H plus 2E. And the iron, it gains the electrons to give you Fe2 plus. Balance the electrons. That's what you need to do. You need to balance the electrons, so you multiply these by 2. Cancel the electrons, because now they're balanced and they're in opposite sides. And then add up the left and the right. So hydrogen plus 2Fe3 plus gives you 2H plus 2Fe2 plus. And that's your balance here. 2, 2, 2. That's how you do it. Yep, these are half equations, that's right. We can build this up purely by knowing which one's going to give electrons, which one's taking. We said before that iron is taking and the hydrogen is giving, so that's what we have here. So the change as well, overall change, needs to be made in the apparatus to allow the cell reaction to go to completion. So what do we have here? Okay, so right now we have a voltmeter. In order for it to go into completion, you can change it with a light bulb. There you go. I will post this on YouTube. I think someone asked if this exam board is easier. CAIE, I would say, is the most difficult just because it does cover everything, but it's very similar to AQA and OCR. They're all quite similar for the A-levels. There's not much differences. So if you want to do other exam boards, use CAIE, OCR, and AQA. Even Edexcel is similar, but they just have slightly different terminology. Morning for half an hour, and we're continuing with the rest of it right now as well. Okay, let's start. So First things first, we have this E cell. We are asked to complete the missing value. So you can put that into your calculator and you will get positive 2.30. The graph here is really simple. All you have to do is just combine the E cell and the ln values into the diagram. So you have here the E cell. Let's scale it. So we have minus and we also have 0 there. So I'm gonna put our scale like this. Why did I put it in the center? Because we have negative values. So we're going to put that as 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. And then we have these scales. 1.05. 1.04 down here, 0.6, 0.7, and so on. And then plot them. We have minus 4.61 and 1.16, minus 1.13, sorry, 1.13 and minus 2.3. Mm, 2.3 and 1.07, so that's over here. And then, yeah. Something like that. Oh, this is wrong. There we go. Okay. So now that we have the graph, we can then answer the next one. This equation shows the E cell varies with concentration for this reaction. You've got the E cell equation here. This equation is in the form of the equation for a straight line y equals mx plus c. That's the c, that's the y. No, this is x. This is the y, this is x, that's the gradient. So calculate the gradient first, and then you can use the gradient to find t, basically. So, first things first, we're going to find the gradient. Okay, so this is a trick that my teacher taught me when I was still doing my GCSEs. Well, yeah, GCSEs and A-levels. But basically, when you're trying to find the gradient using a graph, make it as simple for the examiner as possible. The simpler it is for them, the more lenient they are with you. If any of you are examiners or know any examiners, you can ask them if that's true or not. But the best thing to do is to make a triangle, to use. So I'm going to choose that and that. At 2, 1.072. And that one's at minus 3, 1.138. So then I'm going to find the gradient here. It will be 1.138 minus 1.017, 0.072 over minus 3 minus 2. And I get minus 0.013. That's our gradient. So again, in the form of y equals mx plus c, this here is equivalent to your gradient. So minus 4.3 times 10, 5 times t is equal to your gradient, minus 0.013. Therefore, it gives you a value of t, which is 303 Kelvin. And that's it. And you get 3 marks just by doing that. You know your gradient, you know your temperature. No, not you don't know your temperature. You know your gradient, but you have the equation. That's y equals mx plus c. So you know what the equation is to find the t, and then you found your t. Yes, you can use two values that you have already plotted, but make sure you draw the triangle here. Even better if you put a right angle triangle. Make sure you label the values you are using. That makes it simpler for the examiners. And if the examiners find it simple for them to understand what you're doing, they will be more lenient with it. At least that's what my teacher said. Okay, so in experiment 2, in table 2, the electrode potential of Cu2 plus or Cu electrode is plus 0.33 volts. Use data from table 2 and question 0.03.6 to calculate the electrode potential for the Zn2 plus Zn electrode in experiment 2. Give one reason why your calculated value is different from the standard electrode potential for Zn2 plus Zn electrode. Okay. So they said to look at experiment 2 in table 2. That's that one there. We have 0.11 minus 2.3. Okay, what are we looking for? We want to calculate the electrode potential for Zn2 plus Zn electrode. Give one reason why your calculated value is different. Okay. So we want to find the E cell value here. We know the total E cell value is 1.13, and we know the equation there, so I'm going to use that. Take a screenshot. I'm going to put it here so it's easy to go through. Okay, we also know the temperature, which I said was 303, so we're going to use that. So the E cell of experiment 2 is 1.13, so 1.13 equals minus 4.3 times 10 to the minus 5 times 303 times the value of that, which is minus 2.3. So minus 2.30 plus the E cell. Put that into your calculator. You will get E cell potential minus 0.8 volts. So the answer here is minus 0.80 volts. Give one reason why your calculated value is different from the standard electrode potential for Zn2 plus or Zn electrode. This one's a common question. If they ask you for discrepancies, why is this different to the calculated? Why is the actual different from the calculated? The answer is always because of different conditions. So that's what you can say here. Non-standard conditions were not used. How do I prove this? The temperature. Standard conditions is 298 Kelvin. So if we're using 303, it's not standard. And that's how we know this is correct. Any questions? Thank you for the rose. I will be doing GCSEs as well, but I do go through the past papers that people ask a lot. So I got a lot of questions for this one, so I've been doing this one right now. I used good notes for this. Why did you not use 0.33? Where? Oh, this one. Oh, that's because we're looking at the Cu here, but we're finding Zn. So that's what we have there. And yeah. Okay. I think we're going into some, looks like we're going into some organic questions here. So let's go through that. Ethanol reacts with potassium cyanide, followed by dilute acid to form 2-hydroxypropanitrile. Name the mechanism for the reaction between potassium cyanide and ethanol. So we have potassium cyanide and ethanol. We want to see the reaction. It says that we will get 2-hydroxypropanitrile, which means that we combine the two together here. And when you combine the two, it's called nucleophilic addition. Well, if you combine the two, it's called addition. But it's nucleophilic because this is a nucleophile. You're adding the nucleophile into the ethanol. It's not substitution because you're not replacing anything here. You're breaking the bonds in the ethanol to combine with the nucleophilic addition to combine with the potassium cyanide. So you're not substituting anything, you're adding on to the bond. That's why it's nucleophilic addition. They're probably going to ask us to draw it later. So the 2-hydroxypropanitrile formed by the reaction in question 04.1 is a mixture of equal amounts of two isomers. Equal amounts of two isomers. That means we're going to be looking at an optical isomer. That's the keyword. And the name is racemic mixture. That's right. Explain how the structure of ethanol leads to the formation of two isomers. So this means that we have a chiral carbon somewhere along here. That's why we have a racemic mixture. Yep, that's right. You can see planar molecule attack above and below the plane. Yeah, does not rotate plane polarized light. Very good. Looks like you guys did your revisions. So it's planar around the carbonyl group. So equal chance of attack from each side by the nucleophile, which in this case is Cn minus, your nitrile. And then you get your 3D structure. You have hydroxypropanitrile. So that's going to be something like this. 1, 2, 3 carbons. You have your nitrile group and 2 hydroxy, meaning your alcohols in the second carbon. And then it's an optical isomer, so just flip it around. Be careful with this, guys, because I see a lot of the times students will not really care where the carbon will bond to. The carbon must always bond to either another carbon or an electronegative element. Unless you have hydrogen, then that's fine. But if you have OH, you can't bond to the hydrogen. Must be to the oxygen. Same with this one. You bond to the carbon, then the hydrogens. Not the hydrogen, then the carbons. And that's why it looks like this. It's not the same orientation. It's mirrored with each other. So even though it looks exactly the same, when you rotate it, it won't be exactly the same. It's like when you have these two with each other. Let's say we have the tip and the tip here. When you want to rotate it, they will clash. They will cancel out. And that's why it's fine to draw it like that. It's a mirror image. Okay. So the next one that we have is 2-hydroxypropanitrile can be used in the synthesis of the monomer, acrylonitrile. Okay. Suggest a suitable reagent and conditions for the conversion of 2-hydroxypropanitrile into acrylonitrile. So this one you can memorize. we need to know the reagents and the conditions. So I've uploaded into my TikTok videos, you can see it. There's a, what's it called? I have a video where I posted the organic compound flow sheet and also the organic compound flow sheet as well. So we are using this to synthesize the monomer acrylonitrile. That means we're getting rid of the hydroxy. That is reduction. And so we can use concentrated H2SO4 with heat. Or you can say reflux. That's fine as well. Another reducing agent is Al2O3 and heat as well. Either one of them is fine. You can say nickel catalyst, although it's not really preferred in this case because nickel catalyst is mainly for, It's mainly for hydrogenation processes. LiAlH4, that's fine. NABH4, that's fine as well. Draw a section of the polymer polyacrylonitrile showing 3 repeat units. So that means you just need to break the double bonds and repeat itself. So you have CC, hydrogens on the first carbon, 1 hydrogen, 1 nitrile on the other. Repeat this 3 times, 3 repeat units. So C, 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 H, 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 CN, CN. Leave the ends open. Don't put something on it. Don't put hydrogens. If you put a hydrogen, you'll lose the mark. That's the idea behind a repeat unit, that it's open at the ends so that you can have more of it. No, you can't put the brackets and put 3N outside. Not for this one, no. If they ask you for 3 repeat units, you have to draw it like this. It's reduction because you're getting rid of the OH. You're going from an alcohol to a alkene. That's a reduction process. Why can't you put the brackets? The brackets is a singular repeat unit, like this. That's the repeat unit for the polymer. But since they asked for 3 repeat units, you have to show all 3 of them. If not, you lose the marks. So when you show the 3 of them, you don't put them in brackets anymore because you're already showing the different branches or the different chains. The repeat chains, not the different chains. Okay. So the percentage by mass of iron in a steel wire is determined by a student. The student reacts 680 milligrams of the wire with an excess of sulfuric acid, so that all of the iron in the wire forms Fe2+. Then after that, they make up the volume of Fe2+ solution to exactly 100 centimeters cube. They took 25 cm cube portions of the Fe2+, titrate each portion with 0.02 mole per dm cube potassium manganate. Give an equation for the reaction between iron and sulfuric acid. Okay, so that's metal plus acid. What do you think metal plus acid would give you? Yes, I will post this on YouTube. Salt and hydrogen, that is correct. So the salt here will be FeSO4. How do we know the salt? Replace the hydrogen with the metal. And then the hydrogen will leave. Thankfully, it's already balanced, so you don't need to do anything with that. The titration results are shown in table 3. Calculate the mean titer. So for the mean titer, you have to use concordant values. Can anyone tell me what concordant values mean? Yeah, within 0.1 of each other. And that's this one with this one. So you have 22.70 plus 22.60 over 2 will give you 22.65. So you have 22.65 here. Again, 22.9 is not used because they are not concordant with each other. This is AQA, Paper 3, 2019. Concordant value is always 0.1. Give the overall ionic equation for the oxidation of Fe2 plus by manganate ions in acidic conditions. Okay, so we have Fe2 plus with manganate ions, that's MnO4 minus. So let's make the ionic equation here. First things first, we know that's going to reduce it to Fe3 plus. So find the change in the electrons first. So in here, you will lose 1 electron. Balance the oxygens next. So you can balance it with water. So there will be 4 water molecules because you need 4 oxygens. Then you can balance the hydrogens with H plus on the other side. There's 8 hydrogens, so you do 8H plus. And then lastly, the manganese will be on its own, Mn2 plus, and balance everything else. Okay, so we balanced the water, we balanced the H plus already. Let's balance the electrons. That loses 1. This one is minus 8 plus 1 electron, so it's minus 7. So this is plus 7. This one's plus 2. So the change from plus 2 to plus 7 to plus 2 is gain 5 electrons. So this must be multiplied by 5 to make them balanced. This will be 5, this will be 5. That's how you make the equation without knowing how, without remembering it basically. I'm not gonna lie, when I was doing my exams, I just memorized that. State the color change seen at the end point. So we're using potassium permanganate, and that goes from pink to colorless. So here you will have colorless. Next one, name the piece of apparatus used for these stages of the method. We want to use 25 centimeter cube portions. You want something that's accurate here. When you want something that's accurate, you can use measuring cylinder, graduated pipette, or a burette. For 25 cm cube, we can use a pipette. You can also say measuring cylinder, but pipette is definitely better. You can say graduated pipette or just pipette, that's fine. That's the one that looks like this. So you have the bulb at the top and then kind of like a thing over there. And it's graduated, meaning it goes directly to 25. For the potassium manganate, since we're titrating it, you can see we get different amounts of it. That means we're using burette. The balance used to weigh 680 milligrams of iron wire has an uncertainty of 0.05 grams. A container was weighed and its mass was subtracted from the total mass of the container and wire. Calculate the percentage uncertainty in using the balance. Okay. So we're looking for the percentage uncertainty here. The uncertainty is 0.05. So that's 0.05, but that's in grams. So this must be 0.680. So 0.05 divided by 0.680 times 100. Don't have my calculator. So I think it's like around 1.5%. Something like that. How many times did we measure it? Did it say we measured it twice? Ah, you're right. We did measure it twice. Yeah, so it's multiplied by 2. What is that? Is that still 1? What is that? 0.01 divided by 0.680 times 100. I don't have a calculator. I think it's around, I'm not sure, 1.5%. I'm just going to say that. But it's basically just that. So the formula for uncertainty is the uncertainty multiplied by the number of readings over the measured value, usually the mean value, times 100. So you're measuring it twice, so you multiply it by 2. I'm going to have this up on YouTube, so if it is too fast, you guys can replay it back and watch it slowed down. It's kind of filled in already because I was doing this with my student yesterday, so I kind of know the answers already as well. Just going to erase that. Okay. So let's see. Which amount of sodium hydroxide would react with 7.5 grams of diprotic acid? What does diprotic acid mean? My YouTube channel is, oh, even I forgot, PCFG study. Yeah, diprotic acid means you have 2 hydrogen molecules. That's right. So that means your acid here, we can say it's H2A plus NaOH. It's an acid, so you have neutralization reaction. You have Na2A plus H2O. Balance. Yeah, that's balanced. Oh, it's balanced now. That's your chemical reaction. So, we know that we have 7.5 grams of the acid. Divided by the MR 150, we get, what was it? I did this yesterday, so I have the calculations. 0.05. So it's 0.05 moles. Now, we want to know how much sodium hydroxide is used. So, use the ratio. 1:2. This is 1, that's 2. So, mole of NaOH will be equal to 0.05 times 2. Let me give you guys a secret. If you guys don't know how to use the ratios for this, I'll give you a formula that I made. Mole 2, so that's the second mole of whatever you're finding, is equal to mole 1 times mole 1 over ratio 1. So mole 1 over ratio 1 multiplied by ratio 2. That's ratio 2 here. So that's 0.05 divided by 1 times 2, and you get 0.1. I'll keep it there for a few seconds so you guys can soak it all in, and then I'll go to the answer. What's the best way to revise A-level maths? Past papers and do textbook questions. I would suggest do textbook questions. This is 2019, AQA paper 3. Okay, let's continue this. So we have mole of NaOH. We know exactly what we want now. You can find which one is the correct one by calculating each of them. You have the concentration, you have the volume. Mole is C times V. How do I know it's 2NaOH? Because I know that it's a diprotic acid, so both of the hydrogens are removed and replaced with a sodium. And the sodium will have 2 of them. So then I balance it, you get 2NaOH there. So now you can multiply it with each other. That gives you 0.05 times 0.05. That's definitely wrong. I'll save you the calculation. It's this one here. You get 0.1 times 1 is 0.1. So that's the one. Remember, volume must be in dm cube because that's in dm cube. So that becomes 0.05, 0.1, 0.1, 0.1. Again, we know that it's N2A because each of the hydrogens are replaced by the sodium. You have 2 hydrogens replaced by the sodium, so you have 2 sodiums. Thank you for the rose again. Okay. So you get the answer there, which is C. Questions? Okay, let's move on to the next one. We have here lead 2 nitrate and potassium iodide react according to the equation. In an experiment, 25 cm cube of a 0.1 mole dm cube solution of each compound are mixed together. Which amount in mole of lead 2 iodide is formed? Okay, so first things first, we have both of them having the same amount. So we was dead. Okay, sorry. So we have here 0.025 and 0.1 mole dm minus 3. That's the volume, that's the concentration. Again, we divide it by 1,000 because we're changing it from cm cube to dm cube. So we can then find the moles. 0.025 times 0.1, which is 0.00025. Now you need to find the limiting reagent. They both have the same moles, but which one's limiting? To find the limiting, you divide each of them by the ratios. That's divide by 1, that's divide by 2. So 0.0025 divided by 2 is for Ki. Will be 0.000125. So Ki is limiting. And so the moles of PbI2 will be the same. PbI2 is equal to a singular Ki, which is also a singular PbNO32. And so the answer is that, which is 1.25 times 10 to the minus 3. And that's that one. How do you know when a question is about limiting reagent? We know when it's limiting reagent when they give you basically when they give you anything about both of them. So if they give you masses for both, that's limiting reagent. If they give you concentration and volume for both, that's limiting reagent. So that's how you know. So again, we have the volume, we have the concentration, you can find the moles. After finding the moles, you need to find which one's limiting. That's going to be the Ki, because when we divide by 2, it's 0.0125, while the PbNO3 stays as 0.00025. So that's limiting, that's smaller. And then afterwards, we know the ratio is going to be 1 to 1 for all of them. So the mole of PbI2 is 1.25 times 10 to the minus 3, which is the first one. Okay, next question. Nitrogen dioxide is produced from ammonia and air as shown in these questions. What is the enthalpy change? Okay, first thing you want to do is to see which one you need to balance. To do that, you can check which ones are the same on opposite sides. I can see there's NO here and NO here, so I'm going to balance that. I'm going to balance that by multiplying by 2. And so this will become minus 230. And then you just add it up. Minus 909 plus minus 230 minus 1139. Very simple question for that one. Very, very simple. Any questions on that? Yes, you can always do that when you have the same element on both sides. Which change leads to a higher concentration of SO3 in the equilibrium mixture? So we know the forward reaction is exothermic. How do we know that? Because the enthalpy change always tells you forward reaction. Forward is exothermic. That means what you want is low temperature, not higher temperature. So that's wrong. Catalyst will never change equilibrium, so that's not the answer either. Lower pressure, let's check if that's right. If we decrease the pressure, it moves the equilibrium to the side with more moles, so it goes to the left. So that one's wrong. And the answer is A. That's right. I'll go through GCSE sciences. I've been getting more requests for A-levels, so if a lot of people are asking for GCSE, I'll do GCSE as well. For pressure, increasing pressure moves equilibrium to side with less moles. So if you decrease, it goes to more moles. That means it goes to the left because there's 3 moles here, but only 2 here. Yes, you always use limiting moles. Next one, the result of an investigation. Okay, this one's simple because they already gave you the rate equation, thankfully. So you just replace them. So find the K first. You have 0.40 equals K, 0.200, 0.50 squared, and you find K. I think K is 8, if I'm not wrong. And then afterwards, you just plug it in. The rate is 0.800 equals 8 times 0.60 x squared. And then you get a value from that, which will be 0.40. This one's just a matter of plugging in the information. Next one, we have the equation for the reaction between sulfur dioxide and oxygen is shown. In an experiment, 2 moles of sulfur dioxide are mixed with 2 moles of oxygen. The total amount of the 3 gases at equilibrium is 3.4. What is the mole fraction of sulfur trioxide in the equilibrium mixture? So that's the one where you use ICE, but to be honest, I don't like ICE, so I use a different one. I like start, equilibrium, and end. At the start, we have 2 moles of each of them, and the product is always 0 at the start. Then it says the total of the gases at equilibrium is 3.4. And since we don't know any of them, I'm going to put the product as x at the end. We always start with the products. So put the product as x. The change will be x. Use this to find the moles of the rest using the ratios. This one, ratio is 2 to 2, so it's the same. From SO3 to O2, the ratio is 2 to 1, so that's divided by 2. And then you can find the change by taking them away. 2 minus x over 2, 2 minus x. 2 minus x will then be added with 2 minus x over 2 plus x equals 3.4. Why did I add them up? Because it says here that the 3 gases give you this amount. Solve for x and you get the answer. You can do this for KP questions as well, KC questions, it's the same method. And then you can solve for x, in this way. 2 plus 2 is 4, minus x plus x is 0, so you get minus x over 2. Equals 3.40. Minus x over 2 equals, take away 4 on both sides, minus 0.6, x is 1.2. Okay, then we have nitrogen reacts with hydrogen in this exothermic reaction. Which change increases the equilibrium yield but has no effect on the value of equilibrium constant? So we want something that has no effect, so it can't be temperature because temperature affects it. Can't be a catalyst because it doesn't do any changes in the equilibrium. So it's either one of these. It's not catalyst because catalyst doesn't change the equilibrium. It increases the rate, but nothing to do with the equilibrium. So that means it's between B or D. D, decrease the total pressure. That means you're decreasing the system's pressure. And that reduces the yield because it goes backwards. So that's definitely wrong. So what you want is B. No effect on equilibrium constant, not equilibrium, but yeah. Then we have the next one, which is the EMF value. It's right equals left. Sorry, right minus left. So it's just 0.34 minus 0.44. And that gives you 0.78 positive. A, that's right. Very good. Okay, the other two are pretty simple. I'd like you guys to answer 14. What would you say is the answer? B is correct. It's helium. The atom with the greatest ionization energy is always the noble gases, and definitely the ones at the very top because it's the smallest. And so it's B. What is the correct observation when barium metal is added to an excess of water? What would you say is the answer? Yes, you can ask a question. Barium is in group 2. The first thing you need to ask yourself is this. Is the product soluble? Barium plus water gives you BaOH2 plus hydrogen. And yes, you guys are right. Barium hydroxide is soluble. Barium hydroxide is soluble. That means it's colorless solution. So it can't be C, can't be D. Must be A or B. And we have a gas forming, so it must be B. That's right. I will be doing these lives every day for the Easter break, and then after that every weekend until May 18, where I'm done with uni basically. So after May 18, I'll be able to do it every day for literally 5 hours if you want me to. Although I think I have like a million lessons at that time, so. We'll do one more and I have to go after that. Because I have to do my coursework and I am very behind. I do these lives usually between 10:30 onwards. I did one at 10:30 today, but then I had a lesson between 11 and 12, so I continued at 12 and so on. An aqueous solution of a salt gives a white precipitate when mixed with aqueous silver nitrate and when mixed with dilute sulfuric acid, which should be the formula of the salt. It's a white PPT, and we're using silver nitrate. That's a clue in itself there. Which element gives you white PPT? Yeah, A, that's right. That's the halogen test, if you guys need to revise that. The halogen test is what you're looking for here. Actually, that's an interesting point. Yeah, because C also has chloride, to be honest. The reason why we're not using KCl is because we're reacting it with dilute sulfuric acid. With dilute sulfuric acid, that's the test for, not the test, but that usually reacts with barium compounds. It can react with KCl, but it would be quite explosive when you have the potassium. So we use BaCl2. And that's what we have here. Okay. I will see you guys in the next live. We'll do one tomorrow. I will be doing the live from 10:30 a.m. tomorrow. We'll be doing any other paper if you want. Comment in my videos because that's how I see what you guys want to do. So the more comments I have on a certain paper, that's the one that I choose to do for the live. So let me know what paper you want me to do. It depends. Tomorrow can be either A-level or GCSE, depending on which one people want. But it looks like a lot of people here want to do A-level. Yes, I do OCR. I am a GCSE and A-level science and maths tutor. I do OCR, AQA, CAIE, Edexcel. So I'm happy to help you with whatever past paper you want me to do. Okay, I'll see you guys. Thank you. I'll post this on my YouTube. Again, YouTube channel is PCFG Study.